Welcome to GATE Lecture Series. Myself Srimathy, Assistant Professor, EEE Department in SA Engineering College. This is our GATE syllabus. Today I will explain topic about auto transformer. This is my outline: auto transformer, circuit diagram, copper saving, and problem based on copper saving. And first, before that, I just recall about what is transformer. The transformer is nothing but transfer the energy one circuit to another circuit. Usually the transformer it is a two part. One is a primary, another one is a secondary. So this is a primary part and this is a secondary part. But as auto transformer, it is the only one part, that the single coil acts as a both primary and secondary. And this is the features of auto transformer. First one is the single winding and voltage regulation, compact and economical, low cost, high efficiency, better short circuit current, and reliable, improved capacity utilization. First one is a single winding. The single winding means compared to the conventional transformer, it is a only one winding. That one winding acts as a both primary and secondary. It is the main advantage of auto transformer. And second one is the voltage regulation. The voltage regulation means the auto transformer provides the variable output voltage. So compared to conventional transformer, it is a better voltage regulation and is most compact and economical because it provides the different voltage supply, and it is a low cost and is a better efficiency and is a better short circuit current. It is a less maintenance, so it's more reliable and is improved capacity utilization. The auto transformer have improved capacity utilization for high power applications. And next, theory part of auto transformer. So this is a graphical representation of auto transformer. The first one is a primary part and second one is a secondary part. So B1 means primary voltage and I1 means primary current, and is the secondary voltage is denoted for V2 and I2 means secondary current. Then 1 and 3 section, I assume that is the 1 and 3 section is primary term N1 and N2, 2 and 3 section I denoted secondary term N2. And we have to compare both section primary and secondary, and the equation is V2 divided by V1 minus V2 equal to N2 divided by N1 minus N2. And cross multiply each terms, we have to get V2 N1 minus N2 equal to N2 into V1 minus V2. And solve this equation and cancel the similar terms, and final equation is V2 N1 equal to N2 V1. And as a transformation ratio K, the formula is V2 divided by V1 equal to N2 divided by N1 equal I1 divided by I2 equal to K. That is the transformation ratio of auto transformer. So that is the equation for transformation ratio. Next one, the output power equal to input power. So we have to write the equation for V1 I1 equal to V2 I2. And next, output power. In auto transformer, the power can be transferred primary to secondary as well as inductively and conductively. So first we have to analyze the output of apparent power. The output of apparent power formula V2 I2. And apparent power transferred inductively means D2 into I2 minus I1. Then we have to calculate the I1 value. So I1 divided by I2 equal to K. So I1 equal to K I2. So substitute the I1 value in this equation. So V2 I2 minus K I2. And solve it. V2 I2 1 minus K. And final answer is V2 I2 1 minus K. The input power equal to output power. So the final answer is V1 I1 1 minus K. Next one, power transferred inductively means input into 1 minus K. If it is needed for power transferred conductively means input minus input of 1 minus K. And final answer is K into input. And next one, saving of copper in auto transformer. Already I told that in auto transformer there is only one winding. So the copper losses is less compared to the conventional transformer. First one is a volume and weight of copper is proportional to the length and area cross section of conductor. Next one is the length of conductor is proportional to the number of turns and cross section depends on current. And third one is weight is proportional to the product of current and number of turns. First, we have to analyze the total weight of copper in two winding transformer. Total weight of copper in two winding transformer is proportional to N1I1 plus N2I2. That means the primary part and it is the secondary part. And next one is weight of copper in section auto transformer. In auto transformer, we have to separate the two sections. First one is the first section is 1 and 2 and second section is 2 and 3. So, we have to write the equation for weight of copper in auto transformer. First section 1 and 2 directly proposed to N1 minus N2 into I1 and second one 2 and 3 section N2 I2 minus I1. So, the total weight of copper in auto transformers added two sections, we have to get the total weight of copper in auto transformer N1 minus N2 I1 plus N2 I2 minus I1. And next, weight of copper in auto transformer divided by weight of copper in ordinary transformer. So, weight of copper in auto transformer equation I1 N1 minus N2 plus I2 minus I1 into N1 divided by weight of copper in ordinary transformer. We have to already find out it I1 N1 plus I2 N1 and solve this equation. Finally, we get N1 I1 plus N2 I2 minus 2 N2 I1 divided by N1 I1 plus N2 I2. And we have to separate this equation 1 minus 2 N2 I1 divided by N1 I1 plus N2 I2 and input power equal to output power. So, final similar terms will be cancelled. So, I1 cancelled, 2 will be cancelled. So, final answer 1 minus N2 divided by N1 is equal to 1 minus K. And weight of copper in auto transformer means 1 minus K into weight of ordinary transformer. We have to substitute the value and finally we have get answer for saving in copper K into weight of copper in ordinary transformer. If it is the needed for saving of copper in percentage means K into 100%. That is the formula for weight of copper in auto transformer. So, next one is conversion of two winding transformer into auto transformer. It is a two type. First one is the additive polarity and second one is the subtractive polarity. And first one is additive polarity of circuit diagram. So, additive polarity is nothing but is a step up transformer. It performs the step up transformer. The first one, it is a primary voltage and it is a secondary voltage. It's a conventional transformer, but we have to use in two auto transformer means it is a primary and it is a secondary. The high voltage terminal and low voltage terminal diagonally connected together means we have the added primary and secondary. So, the value secondary is high. So, that is the result in step up transformer. In the circuit diagram, the current flow towards the common terminal. So, the current flow is denoted in this diagram. And next one, subtractive polarity. Subtractive polarity means it is a step down transformer. Step down means the high voltage terminal and low voltage terminal connected directly. So, we have to subtract the high voltage, low voltage. So, finally, we get output in low. So, it is a step down. In this circuit diagram, the current flows away from the common terminal. It denoted for in the circuit. And advantage of auto transformer. It is the most cheaper and smaller size and more efficient. Losses is very low and low exiting current and better voltage regulation. And disadvantage. It is a large short circuit current. It only useful for the moderate smaller voltage changes and risk for high voltage affecting the lower voltage circuit. On application, auto transformer is widely used for the interconnecting system like a transmission and distribution purpose. It is also used for the adapting machineries and is starting of induction motor and synchronous motor is widely used for the auto transformer. An auto transformer compensating the voltage drop in distribution transformer. It is also called for variable auto transformer. And next, problem based on copper saving. In shown figure, the auto transformer supply load 2 kilowatt and 230 volt from 400 AC supply. Find the current between AC and BC and neglecting the losses and no load current. Also find the copper saving percentage of auto transformer instead of two winding transformer. Assume it a purely resistive load. So first, for the given data, output power. The output power means 2 kilowatt and primary voltage 400 and secondary voltage 230. So what is the given data? Output power. Output power 2 into 10 power 3 watts. This is the output power. Next, primary voltage 400 and secondary voltage V2 is 230. That is a given data. So first output and purely resistive load means it's a cos phi value is 1. Purely resistive load means power factor is 1. So the output power formula P output equal to V2 I2 cos phi. So already we know the value for P output power. So 2 into 10 power 3. 2 into 10 power 3 equal to V2 value secondary voltage 230 into I2 is unknown current. Next cos phi 1. So we have to solve this and finally get 2 into 10 power 3 divided by 230. So the I2 value is approximately 8.69 amps. So next we have to find out the transformation ratio K. So transformation ratio K means V2 divided by V1. So V2 means secondary voltage 230 and primary voltage 400. So the transformation ratio K 0.575. And next we have to find out the current. Already I find out the current I2 value. Next we have to find out the current I1, primary current. So K equal to I1 divided by I2. So I1 equal to K I2. And substitute the value 0.575 into 8.6. And finally we get I1 value 3.99 amps. Next, there is a current flow direction path for given circuit. So I1 is a primary current. We have to find the AC section current I1 and DC section means the current is denoted for I2 minus I1. Already we find out the value for I1 and I2. So the I1 value for 3.9 amps and I2 8.69. So subtract to I2 minus I1 and finally we get 8.69 minus 3.9. So the final answer is DC current. So the final answer of DC current. Next one, copper saving percentage. The copper saving percentage formula in saving of copper percentage K into 100%. The transformation ratio K value 0.575 into 100. So the final saving copper percentage means 57.5%. Thank you all. We have to discuss about next class.